Hello and welcome to yet another episode of Smart Indian Agriculture on the Federal.com. I am Vivian Fernandez. Will India run out of luck after 3 consecutive years of normal or excess rainfall? Will the coming monsoon season end in a deficit? The Climate Prediction Center of the National Oceanic and Atmospheric Administration of the United States has forecast a 49% probability of El Nino occurring in June, July, and August this year. El Nino happens when the sea surface temperature over a 6 million square kilometer area in the Pacific at the equator, just west of the international dateline, is half a degree centigrade or more higher than the average of the previous 3 decades. India will be in a hard place if monsoon is below normal and the Rabi wheat crop also is affected by rising temperatures. Already, rice and wheat stocks are running low, and severe weather aberrations will strain them further. To discuss the possibility of a rainfall deficit, we have with us Dr. Sivananda Pai, who led the Indian Meteorological Department's long-range forecasting team till 2021 until his deputation as director to the Institute for Climate Change Studies in Kottayam. Dr. Sivananda Pai, thank you very much for making the time and for joining us. Dr. Pai, 49% probability of El Nino occurring also means that there is a 51% chance of El Nino not occurring. So should we take a bet on optimism?
Yeah, in fact, that forecast that you mentioned was early February forecast. Now mid-February forecast has come from IRI also. And that is based on around 16 global models actually, and around 4 statistical models. And together they are indicating around 60% probability of El Nino after June, July, August season. That means 3 months, and it is continuing. So which means that compared to early February, now the probability has increased for an El Nino event. And also more important is that during that time, that period, the probability of climatological probability of El Nino is around 25 to 30%, which means the forecasted probabilities are much more than climate probability. Therefore, we have to be much more watchful about this forecast. Though, because of springtime predictability barrier, which we generally mention, that means that El Nino or La Nina phenomena starts generally during March, April, May, the spring season of 1 year, and slowly that grows and peaks during the winter and ends in the next spring season. So generally anything predicted in the early part of the phenomena or end part of the phenomena is difficult to, the predictability is less. However, since it is consistently 1 or 2 months it is showing, some value has to be given, and we should continue to watchful for the next, up to April, May. So if that persists, there is almost much more probability, the chance for El Nino will become more.
Dr. Pai, we have had 3 consecutive years of normal or excess rainfall. So does it normally follow that, when we have this kind of a sequence, generally we end up in a deficit? Because there have been years in the past when we have had 4 consecutive years of normal rainfall and then a deficit followed. For example, 2005, 2006, 2007, and 2008 were 4 years of normal rainfall, followed by 2009, which was in deficit. But of course, in 2010 and 2011, we had normal rainfall, followed by deficit in 2012. So there is no pattern, I would imagine.
See, if you are correct actually. So if you see in the 1940s, almost every year was above 100%. Even that was the case most of the years. Even in 1950s also was almost similar thing actually. Okay. So, but if you see that, we have got an epochal variability. That means a multi-decadal variability where early part of this, this century, last century, and prior to that, we were passing through a below normal epoch, which means that most of the years were below normal, below 100. But and after 30s, 40s, it changed its signature to above normal, and late 70s and early 80s again it went to back to below normal. So just to say that we are in a period, in an epoch where most of the years should be below normal. So there is a good possibility, naturally, when you have got 3 or 4 above normal rainfall, there is more possibility that since we are going through a below normal, there is a more possibility to be a below, less than 100. I will not say it's a deficient. And in addition to that, we have got an El Nino prediction, though as I said earlier, we need to wait to get a much more thing, to be more consistent. So if you take into both this account, then there is a good possibility to be less than 100. Again, I will tell you another statistics.
But Dr. Pai, see, there is no one-to-one correlation between El Nino and rainfall deficit in India, because I was reading the economic survey just to see how rainfall has behaved over the past few years. And the economic survey of 2013-14 says monsoon was deficient in India by 10% or more during 6 of the previous 10 El Nino episodes. So whenever there is drought in India, there will be El Nino, but not all El Nino years are drought years for India, isn't it?
Exactly. All drought years are not El Nino. But if you see the major drought years that had happened in recent years, you can see 87, okay, 2002, 2004, 2019, 2015, all were deficient, all are associated with El Nino years. And another statistics I will tell you, after 1950, there were 15 El Nino years. 9 of them were less than 90%. That means more than 50%. And 4 of them between 90 to 100, which means that if you add together, 13 of the 15 were below 100% or less than that. And only 2 years it was 90 to 100. Significantly, 1997, which was the strongest El Nino during the last decade, was a normal monsoon year. But that time it was a positive IOD. So you are correct that you have to take into account other parameters like IOD, snow cover, Eurasian snow cover, or even the intra-seasonal variability that happens during the season. They all finally decide what will be the signature of the monsoon in a season. So we cannot exactly say, but since there is a good possibility that when it is an El Nino to be below 100, because 13 out of 15 is a very good. So I only said possibility of less than 100 only.
Okay. Now you mentioned about IOD, or the Indian Ocean Dipole. Can you explain what that is?
Actually, Indian Ocean Dipole is the temperature difference between Equatorial West Indian Ocean and East Equatorial Indian Ocean. So this two signature, that is why it is a dipole, two different signature anomalies. So when the Equatorial West Indian Ocean is a positive and Equatorial East Indian Ocean is a negative, we call a positive IOD. And that is generally favorable for a good monsoon, particularly over central India. Okay. And when it is a negative IOD, it is the opposite, that there is a less, possibility of below normal rainfall in the central and neighboring areas. Now, at present, the forecast of IOD is a neutral during the monsoon season. Generally, it's not El Nino like El Nino phenomena. It is not you don't have a large memory. Memory means you don't get an indication well prior to the phenomena, only 1 or 2 months, because only around July, August, IOD takes place, and by November it weakens. Okay, and its impact on monsoon also is a very weak compared to the ENSO phenomena, that El Nino or La Nina. Though sometimes it can modify the association between El Nino and monsoon. And then what happens within the season? Number of low pressure systems forming, MJO activities, so they all ultimately, they also provide some, uncertainty during the monsoon. So we have to take into account all that factor. That's why you correctly said all droughts are not El Nino. And there is a but most of the El Nino years are you have got below normal or below 100 possibility.
So the Met Department uses 5 predictors: sea surface temperature gradient between North Atlantic and North Pacific, Equatorial South Indian Ocean surface temperature, East Asia mean sea level pressure, Northwest Europe land surface air temperature, and Equatorial Pacific water volume. I would imagine that the Equatorial Pacific water volume rises when there is El Nino. Now, of all these 5 parameters, how much of importance will you give to El Nino? Is it the main driver of monsoons in India?
Actually, see, El Nino is the major driver of interannual variability, that year-to-year variability of not only monsoon, any of the phenomena in the globe. Interannual variability mainly significantly influenced by the El Nino. So El Nino is generally given maximum important, but other regional factors like what you said, Eurasia, East Asia pressure, etc. They are all regional factors. Okay, though in some years they become very dominant, maximum importance is given to El Nino as far as the monsoon is concerned.
What I was
Yeah.
basically saying is that, sometimes the temperature in the Pacific, it increases by half a degree centigrade, but the severity of the deficit in India has been much more than when the surface temperature in the Pacific has been higher, 1.5 degrees centigrade. So how do you explain this?
See, generally the monsoon that we happen, it's an atmospheric phenomena. And what we call El Nino, they are again is the oceanic. Now there is actually a phase difference between what happens ocean and that reflected in the atmosphere. So there is a lag actually. Sometimes it quickly, what we call coupling. There is a strong coupling some years there is a weak coupling. So if there is a very strong coupling, a small changes that is taking in the Pacific will be reflected in the atmosphere over the Pacific, and that will have a remotely impact over the monsoon. If that is not very strong, so that coupling also is an important, and therefore you cannot have a regression type of equation. If there is a very strong intensity, the impact will be more, not like that. So we also have to see how the coupled systems are being coupled each year, that there can be a variation. And also, as I said earlier, other factors also you have to see, like IOD and other factors, our land surface temperature, our regional factors. So if regional factors are favorable for a good type of condition, naturally the link between monsoon and El Nino will become weaker. Okay. At the same time, if they are also opposite, they are also impacting negatively, the coupling will become more stronger. Okay,
Yes.
so that's why you can't have a direct intensity cannot be directly given as a measure of the rainfall. But definitely there will be a anomalous subsidence happens during El Nino, and anomalous rising motion happens over the monsoon season. So there can be some changes in the atmospheric circulation leading to change in the monsoon rainfall. And again, another factor is a monsoon is a planetary scale system. From India to it covers all Indo-China region up to there, it will happen actually. And not only the shift impact of El Nino happen, there can be slight southwest, east-west shift of this entire planetary system can take place. So therefore, what will happen? Though monsoon will be strong, western end, which is India and the other this western side region, that may be weak, and you may get eastern side more rainfall. So as a whole, if you take monsoon was strong, but some year your entire western part will become more stronger, eastern part will become weaker. So together it is a strong. So again, within the monsoon system itself, which regions are more stronger? So that is why monsoon is a very complicated phenomena, and prediction is a very difficult thing. So therefore, unless you are really expecting have a very strong risk, you should just take it as a precaution or initial, what is likely large scale feature, that is only you should take into account. And thereafter, you also should use extended range prediction during the season, which will give you for next 1 week or 2 weeks much better, then 3 and 4 relatively less predictability, and use those information also taking decision making. And similarly within the week itself, which part of the week, which days of the week will be more significant, more rainfall or less rainfall. For that you have to take a daily forecast, that is a short range forecast. So only when you take into account long range, extended, seasonal forecast together, it helps you in a decision making. Okay.
So this year we have had this peculiar situation, like last year, where temperatures are rising end of February and in March. Last year, for example, the Rabi wheat crop, it shriveled in Punjab and Haryana, and we had a loss of output in these two states of 4.5 million tons. And we were only saved because there was a similar increase in output in Madhya Pradesh. This year, again, we are seeing rising temperatures, and the IMD has said that maximum temperatures are rising by 3 to 5 degrees centigrade. Is there a possibility of the Rabi wheat crop getting affected this year as well?
See, I am frankly speaking, I am not a field observation. I have not seen there, and I am not an expert of agriculture. But naturally, I know that if temperature increases, there can be yield decrease can happen in wheat. So again, depending on whether it's a harvesting, how much harvesting has been done, or which are still lying there, because some late sowing also might have happened. So that all depends on actually. So I'm not in a position to tell you exactly, because we also had a less rainfall and in the initial part, and less cloudy thing. So if early sowing might have done, they could have been harvested early. So impact, I am not in a position to tell exactly.
Got it, sir. So is it possible for the country overall to be in rainfall deficit, but for certain geographical areas to get normal rainfall or even excess rainfall? Can the geographical distribution vary?
Yes, definitely. See, if we see the climatological itself, you will see that we have got a maximum rainfall along the west coast because of the orography, and you have got a northeastern part. Again, orography plays a very strong part along the Himalayas. And then you have got a northwest Rajasthan, and where is a minimum rainfall, and even Pamban in Tamil Nadu, which is the rain shadow area because of the Western Ghats. So what we call is that these are permanent, this one drivers, because orography don't change. So if you have got a very strong winds coming from there, you will always get a strong rainfall in the windward side of the Western Ghats. And the same thing happens if winds coming from Bay of Bengal in the northeast, you will get a good rainfall. But important is which is a transitionary type of system, like a low pressure system, or depression occurs. So in each year, what happened is that it's a path, it's a track is different. Some years it will go northwest, some years it will recur, some years it will be more south, some years it will be northeast. So depending on that, each year in the path through which the monsoon system has moved, there you will get a more rainfall, because there is always therefore year to year variation in the spatial distribution of the rainfall, because these are all transitional. Similarly, if you have got a MJO activity taking place, what we call intra-seasonal variability, so in that case the monsoon trough also will move from south to north. Okay, so sometime you will get by the place, south, you get a lot of rainfall. Before it can go to the north, it becomes weakened. That year you get a northern, close to Himalayas, you get a less rainfall, like what happened in the last year, because one after another systems were coming in July, August, September, and we got a good rainfall along the central part and the southern part, but less rainfall in Bihar, that close to Himalayas, the plains of Himalayas, etc. So this happens.
This is like an advance warning for us, so that we can be prepared. Now, you have spent a long time at the Indian Meteorological Department doing long range forecasting. How much of an advance warning do the farmers require? What I'm driving at is how resilient is our agriculture, and how much of an advance warning do our farmers require to be prepared? Is it possible for them to change their cropping patterns, for example, with let's say a 15 days notice?
Yeah, I think we can generally give. I think even farmers themselves agree that if we can give a 15 days early forecast itself, they can do a lot of things. Okay, so that's why you will see that India Meteorological Department also giving agromet advisories. In two type of advisories they give. One is for 5 days every week, twice they do. I think Monday and Thursday they do that, and it is given for next 5 days. This actually helps you whether crops, depending on its what stage they are, whether irrigation has to be done or not. Okay, so if you assume that and in addition to that, you also go for extended range next 2 weeks. Okay, so many times these things has happened. For example, some years I had noticed in Maharashtra, when people got a lot of rainfall, in the beginning, earlier some years, people got a good rainfall, and then there was tendency go for a sowing. But they were advised not to go for sowing because the extended range forecast was telling that after 1 week there will be a significant deficient rainfall.
Sir, at the Institute for Climate Change Studies, what have you observed in terms of monsoon? How has climate change affected the monsoons? Do we have more dry spells now? Do we have more episodes of very heavy rainfall followed by long dry spells? How is climate change affecting the monsoons?
See, the last 100 or 21, 22 years data in the Indian rainfall, that we have got. As I said already, we are passing through a below normal epoch. And if you see the long-term trend, there is a slight declining because we are in a multi-decadal oscillation. So if you put a trend type of thing, it shows slight decrease, which means that overall monsoon rainfall is kind of assured. That means in 70% of the year, you will get rainfall between -10 to +10. That is almost assured. And another assurance is that around 1 plus or minus 10 days or so, onset will take place up to September. So these are all the kind of assurances that you get. But the problem with the climate change brought is that the total rainfall, though, is not much changing. Though I am saying multi-decadal, there are in most of the years extreme rainfall events are bunched together, and there is a very long period of dry. So therefore, you have to both a lot of rainfall is also not good for agriculture because it will not allow fertilizers and all may because of floods type of situation. It may make a loss actually.
It'll wash off.
And wash off. And similarly, dry period again in a you need a irrigation possibility of these type of things come. So this is being observed, and that is one thing. And another thing is that predicting extreme rainfall events is becoming difficult actually. Sometimes you don't get a very extreme amount is getting, though some areas you will get extreme events getting exact amount is quite difficult for models. So these are all the difficulty that we are observing.
On that note, Dr. Sivananda Pai, for explaining a very complicated and rather obscure subject in very simple terms, thank you very much.
Subscribe to the Federal's YouTube page for more interesting updates.